My name is Kim Lutz. I'm with America's Watershed Initiative. We are a basin-wide NGO that focuses on science and data to inform decision-making and collaboration for collective action across the basin. I know many of you on the call today are familiar with an effort that we've been involved with that we're calling the Mississippi River Partnership Initiative. And that's based on the fact that the Mississippi River is the largest watershed in the United States, fourth largest in the world. And like all watersheds, it functions over a vast and interconnected system. And one of the things that brings us all together is the science and data that inform decision making. So we have been having a conversation with our partners at EDF and really excited to bring this webinar to members of the partnership and people who've been involved with this science exploration that EDF has led to combine forces to really talk about how we get a handle on the science needs in this basin. So with that brief introduction, I'm going to turn it over to Kelly Suttles. Kelly is Senior Research Analyst with EDF. With a considerable expertise in many topics that are pertinent to the topic today, including watershed modeling, GIS, land use planning, climate smart science. So Kelly, over to you.
Hi, everyone. Let me get some slides pulled up and I will share my screen with you. All right, so I assume everyone can see my slides. And I am really excited that you're all here today and that you're interested to learn more about our science strategy to support ecosystem management decisions in the Mississippi River Basin. This report we've developed is based on what we've learned from existing ecosystem restoration programs in the United States. So you can think of this as a best practices guide for restoration programs, or what I'm starting to call, it's our guide to getting the science right. So my name is Kelly Suttles. As Kim mentioned, I'm a scientist with Environmental Defense Fund. And what you will find out today is that there were many scientists involved in the development of this report. I'm just the lucky one getting to share it with you today. So first I want to talk with you or just talk about the need for large-scale ecosystem restoration in the Mississippi River. I imagine most of you are pretty aware that human activities are causing severe stress in this river system, which in turn impacts the communities dependent on the ecosystem. So for instance, in the past 2 years, barge operators have restricted shipments due to low water levels, while elsewhere there was extensive flooding. Meanwhile, invasive carp are destroying habitats for native fish and impacting the fishing industry. Furthermore, high nitrate levels in major cities in Iowa are leading to significant health risks. And the 2023 Kansas wheat harvest was the worst in more than 50 years due to drought and high temperatures. These problems sound disparate, but they are all interconnected with ecosystem health and impact different aspects of our daily lives. The solutions all lead back to one thing: restoring the health of the Mississippi River. So next, I wanted to talk a little bit more about why we developed the strategy. Environmental Defense Fund has been part of and supportive of the Mississippi River Watershed Partnership since it was formed. And you heard Kim kind of explaining that partnership a little bit earlier. We have been part of the process for developing shared goals and creating interest in a basin-wide governance structure. Alongside that, we wanted to ensure this eventual program would have the science infrastructure in place to make the best decisions. So this guide is in support of the partnership's goals and can help with setting targets to measure those goals. So this report is not any type of goal or end in itself. Instead, it's really meant to be a guide for how to achieve our shared goals. So next, I'll take a moment to talk about how we developed this science strategy, and then I will get into the lessons learned, what we learned from the other large-scale restoration programs. So this report has been in development for at least a year and probably more like 2 years. back in October of last year, we convened a panel at the American Water Resources Association annual conference in St. Louis, and we invited 4 experts from the Chesapeake Bay Program, the Great Lakes Restoration Initiative, the Gulf Coast Ecosystem Restoration Council, and Everglades Restoration. We were able to gain so many insights from this group, from these experts. And we also interviewed EPA Hypoxia Task Force science advisors, USGS Great Lakes and Mississippi River scientists, as well as university scientists doing research in the basin. With most of these people, these experts, we shared a working draft, and they provided feedback throughout the process, making it into the final report that we have today. We also did an online survey of scientists working in the basin earlier this year. And in that case, the scientists really were reacting to kind of the high-level ideas that emerged from this report, but they did not see a copy of the report at the time. So now we can get into what we learned from these other large-scale ecosystem restoration programs. As you'll see up there, the first thing is the importance of collaboration. All our panelists really stressed trust and accountability were important to the success of their programs they worked in. The role of a coordinated science program. In each of the case studies we examined, scientific research was already underway when the program was established, as is the case in the Mississippi River today. So this research was not necessarily tied to ecosystem scale goals, nor was it coordinated to ensure that resources were used most efficiently. Each of the programs that we reviewed had to develop a coordinated science program, which served both to coordinate existing work and to develop the tools and processes necessary to support integrated ecosystem scale decision-making. In this way, a coordinated science program adds value to existing smaller scale programs, enabling the development of tools such as ecosystem models that benefit existing programs. So next we have the critical elements of science programs. This is the nuts and bolts of making science work in this context. And I actually have another whole slide to get into this one, because these are really the critical elements that need to be funded as part of the ecosystem management program and institutionalized within it. These are really important. So the next key lesson, we have several key roles for scientists, which I will also cover in a later slide. An adaptive management framework. Science is a tool for policymakers and managers to make decisions, and an adaptive management framework is a really useful tool for that. It's a learning by doing model. And the most important and challenging part of an adaptive management framework is the final step, the willingness to make changes in response to new data. And then finally, we have a scientific infrastructure to facilitate communication and collaboration between scientists. So some examples here are a widely accessible data repository containing standardized monitoring data, a model or linked models simulating the system, and results of model runs simulating different management scenarios. Also funding support for annual conferences to allow scientists to come together and discuss implications for management. And then finally, a process for collaborative work planning that allows federal and state agencies, academics and scientists from NGOs and industry to work together in answering management relevant questions. This could include incentives that reward scientists for interdisciplinary and cross-institutional work. All right, so moving on to the critical elements of science programs. Can dive into that. So we have a set of guiding principles. So examples here could be a recognition of the need to integrate biophysical science with socioeconomic science, a commitment to scientific integrity, a commitment to addressing scientific uncertainty, and an emphasis on science that is relevant to decision-making. Next, we have a set of tools to connect science to management and vice versa. So this is where we have our metrics, goals, targets, and indicators. So these should be developed in collaboration with stakeholders, and they would be used to define desired future conditions and to track whether or not management activities are moving the system towards those goals. We also have socio-ecological and socioeconomic models that reflect our current understanding of the system and how changes in one element affects other elements. And then finally, a comprehensive monitoring program that tracks both leading and lagging indicators. This would provide insight into the impacts of management actions on environmental, social, and economic outcomes. And a monitoring program is critical in testing how well the models describe reality. An example is the Sentinel monitoring effort that is already underway to ensure that we are monitoring the right things and that we're doing it throughout the basin in a standardized way. And then our last area is a set of processes to connect science to management. So examples here are a process for ensuring regular communication between scientists and managers, a process for synthesizing scientific results and translating them into materials that are useful to managers, a process for competitively funding management relevant research, and a process for independent scientific review. That's as needed to address scientific or significant dissent within the scientific community. So next we have the scientist responsibilities. So we identified several responsibilities of the scientists in these programs. This is actually an area where I think it would be good to refer you to the report for the full list because there's quite a few. I did put 4 on the slide here that you can read, and I will add another one that I think is important. So scientists need to quantify the relative benefits of different management scenarios in terms of desired environmental outcomes so that managers can prioritize funding to the most effective projects and approaches. So that brings us to recommendations from the report. And as I've said before, the science strategy is meant to support the partnership's decision-making framework. So these recommendations are ideas from the scientists, and now it's up to the partnership to make it their own and make it useful for their process. So it's not necessarily recommendations to the partnership. These are suggestions for how to begin building a science program. So first, consider what additional science products are needed to make better decisions in the basin. An example of that could be needing a watershed model for the full basin. Next, build on current efforts by the Nature Conservancy and others to develop consensus on monitoring needs across the basin, develop common data collection protocols, and lay the groundwork for a data repository. Publish a science assessment of the state of the basin for a policy audience. Organize a Mississippi River Research Forum to identify the key research questions. And these questions can include socioeconomic concerns as well as biophysical ones. And finally, work through the partnership to begin to develop targets to measure our shared goals. So to conclude, we have a lot of interconnected problems in the basin and we need to act now. The good news is that we already know how to inform decisions through science-based restoration programs, and we can use the science strategy report to help guide decision-making within the Mississippi River Watershed Partnership. So next, I'm going to turn it over to my colleague, Ellen Gilinsky, to introduce our panelists. Ellen has been a consultant with EDF, and she played an important role in developing this guide to getting the science right. So over to you, Ellen.
Thank you, Kelly, and pleased to be here today to have a little bit of a panel discussion among some of the people who were part of the interview process to help develop the report. So I'm going to introduce all of them first, then we'll go to questions. Amanda Gumbert is a water quality extension specialist at the University of Kentucky Cooperative Extension Service. Her work focuses on agricultural water quality issues and best management practice to reduce nutrient losses in watersheds. She has been a part of the SIRA 46, which is the multi-state land grant university partnership working to reduce nutrient losses in the Mississippi River Basin since its inception in 2014. And the SIRA 46 is a science advisory group to the Hypoxia Task Force, and it's the 12 land grant universities along the main stem of the Mississippi. Jason Knouft is director of the Freshwater Policy Institute at the National Great River Center and a biology professor across the river at St. Louis University. He works on human impacts on the hydrology and ecosystems of the Mississippi River Basin. And Jason has been a contributor to the Mississippi Rivershed Water Partnership. So I was very familiar with those deliberations. And finally, Alisha Renfro is the senior manager for science policy with the National Wildlife Federation's Gulf program. And she works to advocate for science-based restoration and nature-based solutions for the Gulf and the Mississippi River. So Kelly, can you get the slide off? Yeah, great, thanks. So I have a couple of questions. I'm going to start with a question for Amanda. Speaking as part of the SIRA 46 advisors, how can this strategy help universities synergize research, teaching, and outreach activities to achieve Mississippi River nutrient reduction goals?
Well, thanks for the question, Ellen. And as you mentioned, I've been involved with SIRA 46, which is a land grant university consortium that works alongside the Hypoxia Task Force and has for a little over a decade now to try to figure out the best strategies that that the land grant universities can bring to the table, specifically in this situation to reduce nutrient losses from landscapes in the basin. And what we have tried to do as a group is to not only adhere to the responsibilities that we each have in our home states and to our home institutions, but also streamline how we can work together as researchers, as extension personnel, at our universities to use those resources to achieve nutrient reduction, reduce nutrient reduction losses, I should say, from the landscape. And so having, some sort of guidance or I guess the collaborative effort of a structure of the science and where things are in a central location, a central structure for organizing that information could really be useful to our researchers, but also in terms of what's going on in the communities on the ground where we're doing our extension work, where we're really working directly with landowners, land managers, and those end users of information that are putting practices on the ground. So I think having this concerted effort where we're all kind of working from the same playbook could be really useful for us as we're at universities, as I'm sure Jason is well aware, we're all, challenged with enough resources to do the amount of work that we know needs to be done in terms of research as well as outreach and instruction. So being able to streamline those resources would be really helpful.
And Amanda, as a follow-up, I know the SIRA 46 is also working on a coordinated communication strategy for all the folks working in the basin. So how does that relate to the science strategy, the work of the Mississippi River Watershed Partnership and others?
Well, you're right. We are working on a communication strategy. We've developed a strategy, and now we're starting to operationalize that in cooperation with input from many stakeholders. Many, I'm sure, of the similar stakeholders who have given input on this science strategy. Having the information at hand, the most up-to-date, relevant science information for us to turn into communication products is really vital. We are have a kind of, we're trying not to have too wide of a range of audiences for the communication strategy, but as Kelly mentioned, this is a very complex system. It's a large system. There's a lot going on, a lot of stakeholders, a lot of users, and a lot of people who don't quite understand how complex the system is. So some of the communication strategy will be to make sure that we can clearly communicate, one, the work that has been done, the work that is currently going on, the need for additional scientific information, but also understanding that this is a long game, to make this basin the best it can be, to provide all of the services that we ask of it, and to understand that ecologically, it's going to take a while for us to see the results of all of the work that has been done, or that we're putting practices on the ground. So that communication strategy would greatly benefit from having this collaboration and having a central place where there's readily available, up-to-date scientific information for us to pull from.
Thanks, Amanda. I'm going to turn to Jason now, put you on the hot seat here. So Jason, I know you have some experiences with other science strategies. So what do you see as the challenges and opportunities in effectively applying a science strategy to such diverse work as is going on in the Mississippi?
Right. Yeah. Thanks for that question. And I'm going to probably reiterate several of the things that Amanda just said, which is probably telling. But I think that, right now within the basin, we have if you want to call it like the intellectual scientific infrastructure to tackle most of the issues that we need to deal with right now. So I don't think the generation of science right now is the major challenge. I think the major challenge right now is, as Ellen mentioned, effectively applying science. And so the real challenge there is to better facilitate communication between the scientists and the end users, which is much of what I think Amanda was hitting on. And by that, I think we need to engage the entire, communication group or communication system in a more continuous way, meaning we need to have reciprocal engagement between the end users and the scientists. So we need the users to tell the scientists what they need, what type of information they need, and what format that information is most usable to them. And so we have to move away from this framework where the scientists sort of generate data and then just leave it at the loading dock and hope somebody comes and picks it up and can use it. We need to have some sort of transmission and effective or transmission of usable data from the scientists, and only with like sort of true reciprocal engagement between the users and scientists are we going to get that. And so, and again, what Amanda noted is that the basin is such a complex system, and I don't think that's fully recognized, across the basin, at least by the people who need the information that the scientists are producing. And so I think we need much better communication and education on how that complex system works and the different interrelationships among that system. And then finally, I think, one of the most important things is we really need to be forward thinking in terms of how we apply a science strategy and how we communicate that strategy in terms of the tools and computational infrastructure that we need, not today, but 5 years from now, 10 years from now, 20 years from now. So, really what we're talking about today becomes a sustainable sort of intellectual and practical infrastructure for users in the basin. And so, a final point that I want to echo that Amanda made is that, a central structure for this would be so valuable, a place where both scientists and, people who need the information can look to as a resource, for information and communication. And so I think those are the challenges and opportunities primarily as I see them.
Thanks, Jason. And since you've been directly involved in some of the goal setting of the Mississippi River Watershed Partnership, how do you see a science strategy like this helping to pull together those goals?
Sure. Yeah. And so if we think about it in terms of the Mississippi River Watershed Partnership, if one of the goals is, taking science and data to inform decision making, then a science strategy is fundamentally important to that because there's coordination. And I think, that one of the issues that we probably all recognize is so many of the water issues across the Mississippi basin and any large basin are place-based. And so, what's going on in Minnesota and how folks need to deal with things in Minnesota is much different than how they need to deal with things in Louisiana or wherever throughout the basin. And so if we don't have some sort of coordination, some sort of science strategy and communication of that science strategy, then we've got, sort of all these disparate efforts, which, make progress. But I think that the real synergies that can be developed among those groups are missed. And so a science strategy is something that I think we can all, at least in some way or another, plant our flag in and move forward with, so at least there's a way to communicate on some shared issues and values across the watershed.
Okay, well, thanks, Jason. Again, both panelists have emphasized the coordination, the infrastructure of the effort, and how a science strategy helps that fit together. So, Alisha, I know that you've had experience in using science to inform policy and planning in your job, and can you share some of those experiences with us and how they relate to the role of a science strategy here?
Sure. So in Louisiana, we have a science-based process to build out a blueprint for what coastal restoration and risk reduction looks like. And this has allowed us to be competitive when it comes to federal funding. And unfortunately, it wasn't born out of our can-do initiative. It was in response to tragedy. The 2005 hurricane season was a wake-up call for Louisiana, and that we could no longer kind of do these random acts of restoration and risk reduction, that we actually had to develop a science-based plan to figure out how we invest our limited resources, our money, our time, and in some cases our sediment, to build out a more resilient future for coastal Louisiana. And so this is the Coastal Master Plan process that in many ways echoes a lot of the elements that we've already talked about today as being important for a science strategy. It's an iterative process that is science-based. It uses models that have a representation of how the system works. There's also a network of data collection across our coast. We have 300 different instruments across the coast that are collecting data that we use to update those models periodically as we learn more about our coast, as we have a better understanding of some of the pressures and processes that are happening. We also use predictive models to understand, what does the future look like? What is the baseline? We know we're not going back to the coast we once had. What is the baseline that we're trying to avoid? What's kind of the scary future? And we use that to test different projects that have been suggested by the public, by the science community, to look at what is the list of projects we need to really move forward on. We also have some other places for scientists to plug in. There is some funding available to address some of the specific research issues around implementation of projects or development of the Coastal Master Plan, as well as there are tools that are released after the master plan that allow the public to dig into where projects are and kind of the data that goes into it, as well as some more detailed data for the scientists to get a hold of. So all of this is just kind of showing, we have this process that has largely been successful. We've been able to take kind of the politics out of a lot of our decision making and be really competitive and actually get projects implemented on the ground that move the needle in a really meaningful way. And so while this is kind of a microcosm when it comes to the larger basin, it sort of shows that this is possible. And it is something that I think is going to be really important for the Mississippi River if we actually want to do work in a big way. If we want to be able to get the kind of funding that we really need to address the major issues in the river, we have to kind of develop this larger process that really drives that.
Thanks, Alisha. Very helpful. And also thanks to the other panelists. I'm going to turn it back to Kelly for some further thoughts.
Well, thank you. I want to say thank you to Ellen, Alisha, Amanda, and Jason. Your responses were really insightful and illustrative of different ways that science-based decision-making can be useful in the watershed. Next, Kim will say a few words about how the science strategy relates to the in-person meeting in August, and then I believe it will be open for questions.
Yeah, and before I make my comments, I just wanted to remind people there's a Q&A button at the bottom of your screen. Please put your questions for the panelists in that space, and we'll get to them in just a minute. I just wanted to, thank you for the presentation and for this body of work. For those of you who have been engaged in this process called the Mississippi River Partnership, it's really been a co-creation process of trying to figure out what we as leaders are struggling with in the basin, how those areas might be improved by further collaboration. We know there's a lot of collaboration going on, but where could it really enhance our work in some key areas? What would be those key areas? And then how do we build upon those to build a structure that works for this very unique basin? We've said all along, we want to build on existing structures. And many of you have heard this comment time and time again, but I just love it from Eddie Belk with the Corps. There are many islands of goodness already in the basin. We just need to figure out how to get from one island to another, to get information from one island to the other, and to make connections amongst existing great work where necessary. As we went through the process to build that set of goals, we noticed that a huge percentage, I haven't actually tabulated the percentage, but under each of the goal areas, water quality, water quantity, fish and wildlife resources, recreation, and inland navigation, there were science questions that we had that need to be answered to help us make the best decisions possible. So knowing that EDF and their partners had developed this really thoughtful science framework, we thought it was very timely to bring that in to the discussion, to the partnership, to say, hey, here we have a path forward of how we might incorporate their scientific learnings and ideas into explicitly into the goals of the partnership. There'll be a small-ish, maybe about 75 people meeting in St. Louis at the end of the month that will be taking those goals that a much larger group have developed and trying to determine how to operationalize them. With this plan in place, we thought this was a great place to explore a little further of how we take the ideas in this plan and begin to operationalize them within the context of a Mississippi River Watershed Partnership. So just delighted to have this opportunity to hear more about the plan today from its creators and partners. And with that, I'm going to open it up to questions from those of you on the call today. So again, please put your questions. We've got a couple already, but go ahead and put your questions into the Q&A box at the bottom. So one question that came in ahead of time was, what does the emerging science suggest about future hydrologic regimes in the 5 basins of the Mississippi River watershed? And what are some of the implications of these future regimes for flood resilience, water quality, navigation, and biology of the basin?
Well, that's a great question.
Can I take that actually?
Oh, go right ahead.
Yeah, because I'm gonna plug the webinar that AWI organized for next week where I'm talking about a hydrologic model that we developed for the entire basin that focuses on basically changes in hydrology over the next 70 years and what those changes will look like. And as you can imagine, they're varied spatially. And some parts of the watershed, we're going to see greater variation in low water and high water. We also have a model that predicts changes in water temperature, which has implications for a variety of ecosystem processes. But I think the thing that's really important to take home is this is such a place-based issue, and that certain parts of the watershed are going to experience climate change in different ways than other parts of the watershed, that this comes back to the comment that was made earlier, that we really need sort of a whole watershed model to understand what these issues are going to look like, you know, economically, ecosystems, and so forth. And I won't get too far into this next week, but it might be you know, I've got some pictures and things like that of results and so forth.
Great, thank you, Jason. The next question is, how was the work of the Upper Mississippi River Restoration and Long-Term Resource Monitoring Program, which was authorized in 1986, included in your study?
So Kelly, I think I can get that one if that's okay.
That's great.
Since I did some of the initial legwork. So thanks for that question. And that helps clarify that the strategy is not a study. It's a strategy of how a framework to pull together all of the ongoing work in the basin. So we did not specifically catalog all that ongoing work. And that work, of course, the important work of the Upper Mississippi River Restoration Program is cataloged elsewhere. I think in the partnership documents have a listing of everybody who's working there. And also there was, EPA did a report to Congress a number of years ago where there is like a whole spreadsheet of all the work that's going on. And one of the recommendations of the strategy was to actually have some kind of convening where all of the programs that are going on in the basin that involve science would give presentations, and we could catalog them that way. So I hope that answers that question.
Great, thank you, Ellen. And please, if you have additional questions, if you can put them into the Q&A box. I'm curious if, as I know it's been said that there's a lot of information already out there that's been created by some terrific work, such as the Upper Mississippi River Restoration and Long-Term Resource Monitoring Program and others. And Jason, I know you said that you think we have the intellectual capacity in this basin to answer most questions. Did you all do any, gap analysis, to use that term, of where there are gaps in data that are key areas that concerted effort could help to fill?
That's a good question. And no, that was not really the scope of this effort, but it is probably something, that should be identified as a need moving forward. Because yes, I completely agree with Jason. There's all this great research going on and already done, and just finding out what are the pieces that we still need research on, and again, like kind of stressing those end users. What do people need to know, and where do they find that information? How do we connect the science with the people who need it to make their decisions?
Great. And a comment that folks were appreciative of you sending the link to the science strategy, and an agreement that publishing the State of the Basin report would be great. A further comment that the Army Corps has utilized some Louisiana DNR State of the Basin report for preferred Atchafalaya conditions. So having a similar report for the Greater Basin would be quite helpful. Any other questions from the group? Or from and anything else the panelists? Oops, maybe another one has just come in. Have there been any discussions for the next step of collecting additional data and running the types of models you suggested?
I think I would agree. Yeah, it's beyond the scope of this effort. I think that's kind of in further next steps to be identified. Yeah, wonderful things that we need to do going forward.
Yeah, and again, this may be outside of the scope of the study, but there's another question about, did anyone raise discussions of AI in this effort and how we could use this new technology to our benefit in pursuing a science strategy for the basin?
Ellen, you
Yeah,
did a
well,
lot of the
that did not
interviews.
come up specifically, but I just wanted to give a plug for the National Academy of Science, Water Science and Technology Board, which I sit on, because we're having a call tomorrow where we're discussing that that should be one of our topics about how AI can help us in water science and earth science, can help us find answers, direct our research, obviously with flooding, with, hydrology considerations. So that is like a hot topic. Again, just a comment that I love these questions, because the whole point of having a strategy is so people start thinking about, well, have we thought of this? Can we do this? So, I think that's exactly the kind of thinking and energy that was the idea of the strategy.
And if I can just jump on to follow up on Ellen's comments and the idea of, the next steps for collecting data and running models and the use of AI. I mean, and this comes back to my point about looking forward, is this type of coordination and management is just, there's such a fundamentally computational and computational component to this, and the infrastructure for that, that computation is pretty significant. And so I think as we consider this science strategy and coordination among the watershed, it is really important to recognize that, like, we're running incredibly complex models. We need to leverage things like AI. And, I think, in many ways, we could be the example of how our global large river systems are managed and sustained. And, this is, I think, if we really position ourselves appropriately, we could be impactful beyond what any of us really can even consider right now if we appropriately apply these new computational technologies. But it's not trivial, and I think it's a whole component that we really need to consider as we move forward.
Thank you. The next questioner is asking about data synthesis. And they reflect that seems to be one of the hardest parts, especially given it's different throughout the basin. And wondering if that was discussed by any of the folks you interviewed, or perhaps in some of the existing large basin plans, how did they tackle that synthesis of available data?
Yes, I agree. That is a great question and a very difficult part. And maybe there is a role for AI there as well. But like you mentioned, the data is different in different places. So has to be a component of standardizing data across the basin so that it will be useful at the whole basin scale. And I'm not sure if we have like specific examples from the other programs in terms of how they did their science synthesis and developed how to put it all together. But I think it does need to be, we kind of get at it in the centralized data repository, the need for models, just so that it's all brought together rather than, in separate, smaller monitoring programs and so forth. Did you have something to add, Ellen?
Yeah, I was just going to say that's one of the things in the Chesapeake Bay program. It took a long time to do it, but there was a central data place where you could get the states data. The states maintained their own databases still, but there was a way to get all of the data. And one of the first things that was done in the Bay program for monitoring was to standardize the monitoring for the basin states, the Pennsylvania, Maryland, Virginia, District of Columbia, so that they were monitoring the same things the same way, the same time. Of course, that was, we thought that was a big deal doing that in the 80s, but that was 4 states that then went to 6 states. So we all know how difficult that would be in the Mississippi.
Thank you. Next question. The panelists have talked a lot about communication and continuous engagement between end users and the science community. Do you have a sense of what that might look like, and how do you envision that process?
I'm wondering if I can jump in on that one a little bit. I really feel like this is a role that land-grant universities can play to kind of do some science translation, if you will, and extension systems. That is what we do. We engage with the end user. We take research information and we translate that to a usable format and get that to the end user. And I really think that is a role that we can play. We've done that already in alignment with Hypoxia Task Force and members in our member states, and playing those partnership roles within our states, but then also across the basin. So I do think that would be a role that land-grant universities could really help to fill. And then also, it's not just there's lots of partners, I should say, that are the end users. And so just using the system that we already have for that research translation could be an avenue to approach.
Super. I'm going to read a comment and then go to another question. Someone was commenting on some of the potential adverse impact of data centers on energy, water use, and potentially habitat. So just a comment to be mindful of AI, both the benefits and the potential impacts. Kind of building on the same thread we've been talking about of the existing large regional programs, do any of the panelists know if their long-term data that they're gathering is used to evaluate performance measures or success metrics?
Yeah, totally. In the Great Lakes program, the Chesapeake Bay program, there's reports every year or every other year that look at that. And again, within the Mississippi River Basin, I think there are attempts to look at that maybe in sub-basins to look at trends. I know that, I've been involved with the Great Lakes to Gulf database, where we have done trends on nutrients over a 20-year period after, making sure we were looking at sites that have long-term data sets. And, I know some other, the Upper Mississippi has done that. So totally, that's the idea of assembling all the long-term data that you have, making sure you can compare it, and then looking at success. So I believe that's what we heard from our panelists back when we first started this effort, Kelly, was the importance of that.
And then if I can, I also always like to add in to what Ellen's saying, because I feel like it makes me sound better. But the other thing that we need to think about is that, we can, it's obviously incredibly important to evaluate success based on collected data. But as we move into this new climate space where, the system is operating completely differently than we understand from past data, this is where developing watershed models are incredibly important, because what it allows us to do is to project the system into the future. And then if you can imagine, like virtually modifying the system, and then that allows us to sort of virtually evaluate investments, ecological interventions, restoration, all these types of things. So I think we are truly now in a different place in terms of how science needs to operate across the basin, and it's forward thinking and it's model based. I mean, I'm certainly not dismissing the value of collecting long-term data. Absolutely, that's not my intent, but I think we need to also change the way we think about managing the watershed and evaluating interventions in the watershed.
I'll just add too, I appreciate both of those responses. But Jason, your comments made me think about how I mentioned both monitoring leading and lagging indicators, and our monitoring is, when we're monitoring water quality, that's actually a lagging indicator. We have to wait and see what the result of our management action was, and did it change water quality? But we need to think about leading indicators too, that it might be a change in stressors on the system. It might be a land use change or something like that, but we're able to monitor those leading indicators to hopefully be a little more forward looking and thinking about our management actions, and are they leading to the right environmental outcomes.
And I'll just jump in there and say in what you all just described, I think is a really good example of how clear communication for multiple audiences could be really helpful, because you just described a pretty complex scientific, principle. And, we might hear from audiences, well, we did X, Y, and Z. Why are we not seeing a benefit? And so communicating the complexity and the time involved, that lag time, Kelly, that you're mentioning, to see water quality improvement, those are some key things that we could communicate out about.
There's another comment in the chat of just noting that in the Chesapeake Bay, citizen science data is also being standardized, and quality assurance procedures improved to include that data into the EPA database for criterion assessment. So that I think is a positive note. Because I know there are a lot of citizen science data, because that's a way to both bolster communication interest, and with appropriate standardization could be another tool. Any comments on that? Okay. I think I have come to the bottom of my list of questions. So thank you all for all your great questions, and to the panelists for their answers. Any final thoughts, Kelly, that you want to leave us with, or any of the panelists?
I want to thank everyone for your interest in attending today. I think this has been really nice, and it's nice to hear your thoughts and comments and questions.
Super. Well, thanks everybody. Really appreciate your time, and we'll seed you back 5 minutes, which I know on some days could be a lot. So before you go to your next call. So again, thanks everyone for joining. I hope you'll download the report and take a look. If you have further questions, you can direct them to Kelly and her team. And we look forward to seeing a small number of you in St. Louis at the end of the month to further contemplate how the Mississippi River Watershed Partnership moves forward. And this has been a great tee up to that conversation. So thanks again.